Okay, I think we'll get started. Filing, there's plenty of space. It's always quite interesting to put up a talk about branching and source control strategy because I don't think it draws a big audience, but I think it draws the right audience. These are the people that are going to be really passionate and maybe annoyed about some of the things I'll talk about today, but we're going to find out together. So this talk is called Feature Branches and Toggles in a Post-GitHub world. And this is really my talk is reflecting on some of the conventional wisdom that we've had around the use of source control coming from sort of this continuous integration and continuous delivery movement and re-examining that in the light of what's happened over the last 10 years. We've now got all kinds of different tools and techniques, different ways of working, and I really wanted to look back at all of those things that I just took for granted back in the early 2000s and see if they still apply to how we should develop software today. My name is Sam Newman. I have a company called Sam Newman & Associates. I've gone independent. There is at least one other associate, just before anyone checks. If you're interested in consulting or training services, come find me later. I also wrote a book about microservices, but this talk is not about that. I would suggest you go and buy my book, but there seem to be no books at the O'Reilly bookstall, which I think really just underlines the whole print media is dead thing that's going on right now. But anyway, I want to take you back to a time before microservices, if such a time existed. Back, in fact, to when I first started work for a consultancy called ThoughtWorks in 2004. And I joined, and I was fresh-faced. I think I still had a beard back then. I turned up on my first day at the office, and they said, well, what's going to happen is you're going up to a place called Hemel Hempstead. And I'd heard of Hemel Hempstead in legends, and I knew it to be some place off to the dark and distant north, full of dragons and all sorts of other things. And they said, well, here's how you get to Hemel Hempstead. You go to this platform in Euston, and you stand between the 4th and 5th pillar on this platform, and you'll see other people that will just look like look like you. And you just assume they're your co-workers and say hello, and they'll sort you all out. Surprisingly enough, that works, which doesn't say much for the level of diversity in that organization at that particular time. But nonetheless, I found my way up to Hemel Hempstead. Just to put it into perspective, here's Euston down here, which is where I used to live. And Hemel Hempstead was about here on the train line. And it had some things to recommend it. Not a lot. It was basically an industrial estate where we worked. And we would always get on the train and we'd daydream about, you know what, if we just stayed on that train for just a little bit longer, we could go to Bletchley Park, and that would be much better. We could hang out with like Turing bombs and Enigma machines. But we didn't, because we're dedicated software professionals. I think if we'd been drinking, we would have gone. Anyway, so this brings you on to my job that I was doing at the time, and I want to set a bit of context for the project that I joined. This was a project to create a platform for what at the time was one of, if not the largest electrical retailer in Europe. And they had a project to build a brand new electronic point-of-sale system, and that project hadn't really gone very well, and so sort of the company I worked for had been brought in to help them get that project over the line. And when my company first turned up, it was all a bit chaotic. They were way behind schedule, and we just had to get this thing shipped, and that's exactly what happened. And many releases had gone on, and each of these sort of release branches that they had of this code sort of represented major sets of features. So in a way, each branch of code represented some key milestones and rollouts to certain stores. So you had the R3 branch, which was kind of the current active branch for many of, I think, for much of 2003 and 2004. Lots of changes were being made. There's about 60 to 70 developers at the time working on this project. And they were checking in fairly frequently and shipping out new releases to the store when they had new features to drop. But there'd been a lot of technical debt accrual over this time. This project had been a form of a rescue project. We had to get something out, therefore the corners were cut, and I think that's often the case. You have to actually make the business work. And a lot of that debt had built up, but the R3 branch had gone quite well, and we'd managed to get a bit of breathing space. And so a team had been created to look into some sort of key issues of technical debt in the system, doing things like, okay, we've got 4 persistence layers. Do we need 4 persistence layers? Let's have 1. And also bringing in some newer ways of working, create some new abstractions that would help it easier to create the code. But of course, doing those kinds of changes on the main trunk for the release was going to be disruptive, getting in other people's way. With 60 developers all trying to check in code, having people refactoring at the same time is kind of a bit of a difficult activity. And so they made the decision to create a new branch of code, which is going to be called R4. The idea is that they'd start doing the refactorings on that R4 code branch, they'd pull over the latest changes that had been made in the meantime, and then push that software live, and so R4 becomes the new production release branch. So R4 go off, and the team headed off back to head office to sit in their own little ivory tower doing their work. Meanwhile, those people at the coalface of R3 continued doing bug fixes and rolling out new patches, while the R4 people got to talk about cutting-edge technology like Hibernate. This was 2004, and so this is what was happening. And then, of course, what happened is after they'd done all their refactoring, they thought, you know what, we've made a load of great changes. But now what we need to do is make the R4 branch of code the live production release branch. And so they said, well, let's merge over then all the features that have been changed in R3, because that will be really easy, won't it? And of course, it seemed very, very easy. I believe it only took them about a week to get the code to compile. And then there was a lot of other types of issues, and it all didn't really go as planned. And while no one died, it did feel like a car crash of epic proportions. And this is when I joined. So it turned out that getting the code to compile was just the first step. Then it was doing things like making all the tests pass and just fixing the other bugs that were sort of regressions that weren't caught in the automated test suites. And so they created a team specifically to help fix the bugs that occurred as a result of the merge of these two branches of code. And that was called the R3, R4 Merge Bug Fix Team. So I don't think there's anything that could possibly get your pulse racing more when you're joining a new job, surrounded by these amazing people that have got like doctorates, PhDs in refactoring. But one of my friends has a PhD in refactoring. It's going to be amazing. It's going to be cutting edge technology. And they say, hi, so do you know how to use a merge tool? Anyway, so this was sort of not a great first step, but I did actually learn a lot from this project. And actually, the seeds of continuous delivery started on this program of work. Dave Farley, who obviously was one of the co-authors of the continuous delivery book, was actually the architect on this project. So I'll come back to this in a minute, but of course, at this point, you're saying, well, there's this huge merge, and you had this awful problem of sort of getting these two big branches of code together. But hang on a minute, we have a solution to this problem, right? We have a solution called continuous integration that sort of solved the problem here. So continuous integration is a fairly simple process. It's a fairly opinionated development process, but it's very simple and straightforward. You know, you have this idea that you work on some code on your laptop or your desktop machine. Back then, we had laptops as well. I do remember the client once got burgled, and all of the client laptops were stolen, but ours were left behind, which we put down as a damning indictment of how awful our laptops were. So we work on our machine, checking code, whatever, and pushing in some sort of source code repo. We did not have Git at the time. We had something much, 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 much worse, which is why branches were so painful. And then you check that code into that source control, and then some sort of CI tool detects the change and goes, oh, there's some new code that's appeared. Let me integrate that code together and actually validate it and make sure it works. And it will tell you, yes, your code works, or no, it doesn't. And often the baseline is, does your code compile? Now, of course, some people might laugh at the idea of making sure that your code compiles when you check it in. Believe it or not, I spent the first 5 years at ThoughtWorks mostly working with clients, implementing continuous integration for them to make sure that that was the low bar to entry. But many people would check in code that did not compile, let alone actually work. We have moved on. So this is a basic idea, and there's sort of 3 key rules about what you do with continuous integration. So the first thing is, when you're checking in your changes, you're working with your coworkers, checking in those changes into your mainline, you need some kind of suite to validate the integration. So this is where you're going to do your compilation step and run, say, a test suite to say, yes, not only does it structurally merge as it works, it's compiled, but functionally it works as well. You also have the idea that when you break the build, that it should be the team's #1 priority to fix that build. And so typically here what you would have is saying, okay, you'd probably stop any other check-ins on the main line, and you'd say, the only check-ins that are allowed are to fix that build, and then we can fix the change, and then the build is green again, and people can keep on checking in. This is sort of prioritizing keeping the sort of build releasable in a way. And the other thing you want to do is integrate often, because actually, if you take a long time between integrations, and you build up lots of local changes, and then you check all of those local changes in, you're back to the bad old problem of the big merge. I've been working on this thing for 2 weeks, a month, whatever. I've checked it in, but actually, I've got a whole lot of issues with it. And so that's the other rule of continuous integration, which is very, very clear. The people behind continuous integration have been explicitly clear. Continuous integration is integrating with mainline on a daily basis. There are lots of people that say they're doing continuous integration and aren't integrating on a daily basis. That means you're not doing continuous integration. It doesn't mean that you're a bad person. It doesn't mean that the process doesn't work for you. It just means you're doing a different type of integration that's not continuous integration. That's fine. Now, we were doing continuous integration on our project, but it hadn't helped us. And to understand why, you kind of need to look at what it was we were actually integrating. And really, you could argue we weren't really doing continuous integration at all, despite what we thought. Having a CI tool does not mean you're actually doing continuous integration. Because what we had was a whole team of people working on the R3 code branch. And they were making their changes, and those changes were being validated by a CI tool. We had the other team, who were the Ivory Tower team, working on the R4 branch of code, who were making their changes, and those changes were being validated as well. The issue, of course, is these changes were being validated in isolation. All of the R4 team were integrating their changes together. And those changes were being validated, and those merges were being validated together. All the R3 team were doing the same. But actually, we weren't integrating all the code together. That happened when we did the big giant merge, which, as we said, resulted in a bit of a pain. So this wasn't being integrated once a day. This was being integrated once every, well, I think it took about 6 months or something. Now, historically, part of the reason for this infrequent integration and these long-lived branches has historically been down to our source control tools, that they don't always offer lightweight branches, and the merging hasn't been particularly good. But nonetheless, this idea of integration once a day, this mantra behind continuous integration has been key. And that's been something I've been pushing for many years. Since I was on that project, I saw what happened. Dave Farley was on that project, he saw what happened. And this led to us thinking, okay, what are the other practices we need to do to allow us to keep our code in a releasable state? The fundamental challenge you have to deal with really here is how do you deal with half-finished work? I'm working on a story. The story is going to take me a week, maybe, to implement this. So do I wait until I've finished that feature before checking it in? And that's sort of option number one, right? This is, I'd wait a long time, and then eventually I'd go and check it in, right? Now, of course, here we're worried about things like my laptop getting stolen. We're worried about my hard drive crashing and me losing data. So we don't really like the idea of just waiting to check stuff in. Believe it or not, I have, before I was using source control tools, and there was a time when I didn't use source control tools. It wasn't taught at university, right? When I graduated in 1998 with a software engineering degree, why would you be taught about source control? That's kind of a weird thing if you're doing a software engineering degree. So I would used to email code to myself to make sure it didn't get lost. It sat on the mail server and stuff like that. It's not great. So you really want to put it somewhere safe that allows you the ability to see what changes are made and roll them back. Okay, that's not a great option. Option two of how you can handle half-finished work is actually to make a branch. This is how we now think of feature branching. So I want to work on a piece of functionality that I know is going to take me a while to make a change on. And so I fork the code from head. I make those changes locally on my feature branch. And while I'm doing that, somebody else will make their own branch and work on their feature side by side. So we're making our changes in parallel. We're not getting in each other's way. We're checking that code in so the code is safe and the code can be reverted or viewed or whatever else. And then when you're ready, you finish your feature and you check that feature in, and you sort of integrate with any other change that have been made on mainline, and hopefully been rebasing in the meantime. But of course, you still have the issue that once you go to merge your change in, that a lot of things could have changed on head in the meantime, and you have that sort of collision. Even if you're rebasing from master, that's only a one-way merge. It's not a two-way merge. You have that problem where, okay, I've done the rebase yesterday. Oh, it looks like it's great. I'm about to check it in. But some other coworker has checked in a huge refactoring when I wasn't looking, and now I've got a giant merge to deal with. And of course, you can mitigate this as well by having CI run on the branches exactly in the same way as we had with that electrical retailer, where we had branches of code, the R3 and the R4, were being picked up by CI. The key thing to understand here, of course, is we are still, in this world, we are still deferring integration. The longer those branches live without being merged back into master, which is going to be the code you release, the longer it takes you before you do integration, so we have the associated challenges there. I think I've almost come up with a rough equation about this, which is like when you get down to it, that pain of merge, that pain of integration is kind of a function of two things. It's the size of the merge, the delta. It's how big the change is. And it's also the duration since you last did that merge, right? So if you're able to merge more frequently and you can keep your batch size small, these integration pain or merge pain becomes difficult. But even in environments where you're sort of being sensible about your feature branches, you still can have the problem of the commit race. You've had this, right? You've just done a nasty refactoring. It's really fantastic. It's cleaned up loads and loads of code. But refactorings are hard to merge. And you know, Jane next to you, she's got a change about to go in. And you know that if she checks in, it's going to make your merge really painful. You have to pull it out and fix all the conflicts. So what do? You distract her, don't you, right? You say, look over there, it's a squirrel. And then before she knows what's happening, you've checked your code in, the build's passed, and you've gone to the pub, and you've left your poor co-workers going, it's happened to me more than once. And it can become a bit of a fun game, but really it's not a great practice. Because ultimately you know they're going to get you back. On one occasion, I do remember us, so we're working with this client where you had these corporate controls on your Windows laptops. So if someone tried to enter the wrong password 3 times on the lock screen, it would lock the laptop, and you'd have to go and contact the IT support desk to get them to unlock the laptop for you. And so we distracted one of our colleagues when I was pairing with somebody. We distracted them, and we went in and entered a false password 3 times. Their laptop stopped working, and we could get our commit in. Again, not great, right? And there is this problem, actually, that when you're working on branches, even when you're sort of rebasing from mainline and things, one of the fundamental challenges with these activities is that when you're just adding new code, it's not too bad. I'm adding new features, I'm adding new functionality. But when I'm actually doing refactoring, that becomes much more problematic. Some source control tools are much better now at identifying, oh, you've done a rename. Here, that file is probably this file because it's 95% the same. Git's pretty good at this compared to things like CVS and those other sort of tools I've used in the past. But they're not great at detecting, oh, you've created an abstraction, and this code you've merged from somebody else should actually be part of that abstraction, so it should get rewritten. But our merge tools can't do that, only us human beings can. And so what I have found is in environments where you have long-lived branches, especially, refactoring tends not to happen as much. Because you know that refactoring is a bit of a thankless task. You do a nice abstraction in your code, it becomes your problem to merge that in. So that can be a bit tricky. So we've got branches, and actually now with source control, with longer, with sort of lighter weight branches, this has become much easier than maybe it was in the past. But there's still some downsides here, but we'll come back to that in a minute. Option 3 of how to handle code that isn't yet finished and fully checked in is just check it in anyway, right? To which the correct answer is what? Because what does that mean? You can't just check it in. It doesn't work. It's not finished yet. Well, actually, this is what I practice. This is what a lot of people practice. This is the ideas that came out of that particular project and sort of became one of the main ideas behind the continuous delivery book. And that's this idea of trunk-based development. And the idea here is that everybody integrates into trunk on a daily basis. There's taking that idea of CI and saying that everyone integrates together. And so we're all just working and checking into trunk. We're integrating very, very often. We're also getting very fast feedback on the quality of our software. And we're also breaking up the merge pain. Rather than checking in big things, we're checking in lots and lots of small things, small refactorings, rather than brewing up like 25 refactorings before we check it in. But of course, this doesn't make a lot of sense when you think about a feature that isn't actually finished. So I'm checking code in. How do I stop that code being released? It's like it's in trunk now. That could get released any moment now. And so this is where feature toggles come in. And feature toggles are a key part of making trunk-based development work. And with a feature toggle, what you're doing is you're hiding the partially implemented feature in the running system. And so you say, this thing isn't ready yet, so I'm checking it in. It's in trunk. It's alongside all the other code. But I'm going to put a flag in that allows me to switch that functionality off until it's ready. I can still test it subcutaneously. But then when I'm ready, I flick the flag on, and lo and behold, the software is live. And you can think about how it's implemented in things like user interfaces very easily. So here I've got some web page, and I've been working blood, sweat, and tears for a few weeks now on the super widget. And the super widget is not yet ready to go live. But what I do is I have a configuration file that says, here's my flag, the super widget, and it's currently off. And then I flick it to on, and my super widget appears. And so when I'm ready, I can flick it on. I could also flick it on just for, say, test purposes. So I turn that feature on, test the super widget, but I'm not actually releasing it into production. And people do feature toggles in different ways, configuration files. Some companies use things like flags that they'll pass into their systems. Google famously does flags. And some people might use something like a centralized configuration system to manage those flags for them, allowing them to control the flags dynamically at runtime. So some people use things like Zookeeper or Console to actually store the values of those flags. Now, that's kind of easy to conceptualize when we think about brand new pieces of functionality. I'm adding on something new to some existing system. It's quite easy to see how you can hide those pieces of functionality from your users inside the same code base. But what about if I'm making a change to an existing piece of functionality? Effectively, I've got to create a brand new implementation of some existing piece of functionality, but I've got to keep the old version of that functionality around until the new version is ready to take over. There is actually a way of handling this as well, again, using sort of toggles. There's a product from ThoughtWorks called Go. So Go is an open source continuous delivery tool that you sort of run on-premise. Many years ago, they had made a decision in their product to shift how they handled their persistence layer. And they had been making use of a tool called iBatis. So iBatis sort of allowed you to do handcrafted. It was sort of an ORM mapping layer that allowed you to do handcrafted SQL. And some people quite like it because it gives you more control, but it can also be painful compared to some other sort of more abstracted solutions like Hibernate. And they realized that this wasn't really helping, and they wanted to shift away from that. But obviously, your persistence system is quite tightly integrated with a lot of other things that are going on. Changing that over to a brand new persistence system was going to take a long period of time. But they had the added kicker that they ship software every 2 weeks. And what that means for them is that they make available a download of the software that is being tested and is known to work. So every 2 weeks, if you wanted to as a customer, or now just anybody, you can just go and download it and try it out. So they didn't want to do this change on a branch, and instead they wanted to be able to make this change incrementally in trunk. So integrating it with all the other code, testing it with all the other code, but switching it off until it's ready. And so what they did was they effectively implemented a pattern called branch by abstraction. So rather than using software configuration management tools, so rather than using version control tools as separate branches to keep the two implementations side by side, they kept the two implementations side by side in code using an abstraction point. So they implemented their Hibernate backend and came up with an abstraction layer that sits on top of both implementations. And you had to do some refactoring to repoint all those inbound calls onto that new abstraction layer. They then used a configuration file that allowed you to switch which persistence layer was it being used at any one point in time. It actually took them quite a while to implement, to move over all the calls into Hibernate. And so as they were switching over bits of functionality, they wrote tests that would allow them to test sort of slices of functionality that went through the new Hibernate sort of flow. And then once they were ready to fully switch it over, they actually removed the old implementation of iBatis, and they took the flag away. Actually, so for many years, actually, when you were downloading Go, or Cruise as it used to be called, hidden away in a configuration file you didn't know about was a flag that allowed you to turn that persistence layer between the iBatis and the Hibernate option. Obviously, if you did that as a customer, it wasn't a customer-exposed flag, you'd find that only half the software works because it was a work in progress. So that technique is called branch by abstraction. And what you're doing here is you're trading off using source control to manage branching and effectively and instead creating abstractions in your code to allow you to coexist different implementations of the same functionality. And that's actually something as developers we're quite good at. And this means that your source control story becomes much, much simpler. There are some golden rules around these feature flags. The first thing is if you're going to use a flag or a toggle around a feature, you want to use it in as few places as possible. A good number of places is 1. 2 is acceptable, but I prefer 1. When you scatter these flags all through, there's the same flag in lots of parts of your system, it becomes very hard to know what on earth it does. You also want to remove those flags when you're done. I worked with one client that had over 300 flags that they'd never removed. And they'd left them all in the code, now scattered all over the place. They'd also taken things a bit further. They'd sort of combined their flag system and their configuration system, so you couldn't see what was different. And so between QA and production, they had about over 150 flags that were different between those two environments. It was very hard to understand what was happening at that time. So if you're going to use these flags, remove them once they're done. Use them in a fewer places as possible. There are some interesting side products from creating these abstractions and creating these toggleable pieces of functionality. And that is that they actually can help you when you want to start implementing techniques like A/B testing. In other words, sort of comparing 2 different cohorts to see if a piece of functionality works better for one customer or another. Or with a little bit of work, you can do things like canary releasing. It's sort of interested that, when we take these techniques for granted in terms of how we handle release and how we mitigate the risk of deployments, and actually those same abstractions that you create for feature toggles end up often being exactly the same abstractions you would need to implement these sorts of deployment techniques as well. In fact, there's a new generation of tools out there. These are SaaS-based products that allow you to manage your flags and actually allow you to use those flags to do things like A/B testing and that sort of thing. If you are interested, Split.io and Launch Darkly are 2 tools in this space. I'm a little bit hesitant about recommending their use for all purposes because they do rely on a centralized SaaS platform to manage those flags for you. But they do some really, really interesting things. They can do things like say, okay, you're a beta test customer, therefore you get these flags on, so you can see some new features. Or, you're a customer coming from Poland, therefore you can see this new feature. So it helps you with canaries and 1% rollouts. If you want to know more about trunk-based development, an old colleague of mine, Paul Hammond, has written up a whole lot of experiences about this on a website called trunkbaseddevelopment.com. So this idea of sort of trunk-based development, moving away from use of branches, integrating more frequently, sort of culminated in a way with the release of the continuous delivery book. So this book was released in 2011, although the ideas had been brewing for much longer than that. And the continuous delivery book introduced some interesting concepts. One of the first things it introduced is this idea that every check-in is a release candidate. So before, we had this idea that we check code in, and then at some point later on, somebody was going to go double check that it was all right before we pushed it into production. What that meant was that really the sort of the continuous integration practices we were using in the enterprise space had sort of helped give us more visibility about the quality of our software, but hadn't actually helped increase release frequency because we still had that last mile problem. We just assumed that at some point later on there'd still be a big test and validation cycle. Instead, what continuous delivery said is that you should, conceptually as a developer, treat every check-in you make as something that you would be happy to go into production. And then what you do is you use your automation pipeline to validate whether or not that decision is still correct. Is it really good enough? But the developer starts from the assumption that it is. There are other ideas that came out in the continuous delivery book talking about things like batch size. And these ideas are actually articulated very well by a talk that John Osborne did many years ago called Ops Metametrics. And he reflected on the fact that if you take a long time between releases, then the number of changes in that release build up. The more time between releases, the more code you've changed. So when you do a deployment, you've got a lot more changes that have happened. That means you've got an increased risk that that release might have a problem. And so therefore your releases are more risky. And likewise, if you have a problem, it's harder to fix because it's harder to work out what's broken. In many ways, the sort of surface area in this space is sort of like the risk of that release. And so what happens in these sorts of environments where you've got long release cycles is you do the release, and it's a huge ceremony, everyone's sweating and going, oh my God, it's terrible, it's awful, what's going to happen? And you release the software, and it doesn't work for some reason. And you go, okay, well, it's because we didn't check the toggle setting on the MacGuffin. Right, let's add checking the toggle setting on the MacGuffin to our release processes. And so what you do is, to make sure it doesn't happen again, you get you're extra specially careful on the next release, and you take much longer over the next release. Because you know what? If you take a long time over the next release and you're extra specially careful, it definitely won't happen again. And so you build up these release processes, and it takes even longer for you to get the next release of software out. And guess what? When you do, there's another problem. Now this time we've got it right. We're going to be extra careful next time, put a few more things in, and it will definitely be fine. Lo and behold, a year later, you release your software, and there are more problems. And this vicious circle continues. A lot of the work I do with clients around improving their path to production involves me actually looking at the release processes and recognizing them for what they are, which is sort of release process scar tissue. It's like a thing happened at a time, and we invented a solution for a problem, and we never got rid of that solution, even though the problem no longer exists. It's like, so why at this stage do you draw a pentagram on the floor in chalk and slaughter the chicken? Well, we've always done that. It's never done us any harm. Okay, let's have a conversation about that, shall we? The idea, of course, with this is actually if we can reduce the time to market for our new software, we release our software more quickly, then each release itself is smaller. It's less likely that we're going to introduce a problem. And if we do, it's much easier to identify what that problem is and roll it back, because the scope of each release is smaller. We have other side benefits. It's a release process we use a lot, and therefore it's a release process we're very confident with. It's tried and tested. It works really well. And also, we're shipping software to our customers more frequently. That means that we're getting feedback about whether or not our software actually works in the hands of our customers. And so actually, contradictorily, and this is something that takes a long time often when I'm working with teams in this area, says your problem with your big, horrible, nasty release cycle isn't necessarily to slow it down. It might actually be to work out how we can speed it up. And the place it often starts with is keeping your batch size small, keeping the size and scope of each release small. And that starts with maybe shortening your stories. This happens as well with your commits. If you do lots and lots of small commits, lots of smaller stories, it makes it much, much easier for you to integrate them often, because the size of each change is smaller. And if you integrate often, you're getting more release candidates out there, which makes it much easier for you to ship that code more frequently. And so in many ways, the continuous delivery book was taking these ideas of sort of visibility of quality and rigor around modeling your deployment processes and bringing those together with ideas from the .com world, which was all about fast time to market. And out of that came to what we now think of as continuous delivery. Now, while this was happening, Git was becoming popular. So we should really recognize where Git came from. So Git was a replacement version control system written by Linus to help him manage the Linux kernel. He had had a falling out with the previous company that provided the BitKeeper software and decided to write his own, and thereby, I think, probably effectively destroyed BitKeeper in the process. But his main driver was to make it very, very easy for him to merge patches from multiple different contributors. The Linux kernel is not like your average piece of software. It's not one thing necessarily. Yes, there's a core idea of, say, what a 3.4 kernel is, but every operating system vendor in the Linux space has a slightly different version. And so there's lots of processes of moving patches around, and okay, I've got my local changes, but I'll pull those in from mainline. It's not like most software we create, and so Git was created to allow Linus to process a patch in less than 3 seconds. That was his goal. That's his mindset. It's interesting to note, I don't think many of us are in the same place. There are some great benefits to Git. Firstly, branches are significantly more lightweight. If you look at Subversion, for example, which is still a pretty good version control tool, I think, in the grand scheme of things, branch creation is quite a fraught activity. It's a heavyweight activity. You actually are taking a complete copy of the whole software, and so therefore branching is a higher ceremony activity. You don't want to do it that often. As a result, and often then the tension is to keep that branch around for a long period of time, otherwise that whole repo size grows as a whole. But here in Git, branching is a really simple operation. It's because of some really smart work with data structures. Also, it got a lot better at managing the merging of text. Because of the ability to process patches quickly, they had to get better at doing structural merging. So understanding, okay, well, I've just moved those code blocks around. This is a simple rename. And so the automatic merging capabilities for text got a lot better. But we still do need to recognize that it doesn't really do anything for refactoring. Refactoring a process is like, well, source control does textual merge, the structural merge. It doesn't do semantic merging. What I mean by that is I can't see that what change you made on your branch or your check-in was actually a creation of a brand new abstraction. We solved this problem in, say, collaborative documenting editing by using a process called operational transforms. You don't store the delta, you store the operation of what a person did, and then you can reapply those operations. There are tools out there, like Semantic Merge, that actually can do this, but it requires you to sort of buy into the whole IDE process because it needs to capture the refactorings you make in order to be able to merge those things together. This might be the future, but it's not our present. And of course, Git was sort of getting some people interested, but what really pushed it into the mainstream, whether or not Linus likes it or not, and I suspect he doesn't, that was GitHub. It's interesting to think that GitHub is, in the grand scheme of things, not that old. 2008, GitHub launched, and I think it was their third release. They actually put live their pull request feature. And the pull request feature was kind of interesting. It was in there from the very, very beginning inside Git. GitHub created their own implementation of GitHub, and it's quite interesting if you look at the mail thread where Linus loses his shit over how they've done it. It's quite funny. But they put this live to give you a nice little, the ability now to make a quick branch of someone's code, make a change, and let them know that this change should be merged back in. Previously, before this, if you wanted to contribute to an open source project, you had two options. Your two options were check out the source code, do the work locally, generate a patch file, all hail Larry Wall for the patch format, stick that in an email and send it to the committers and say, can you take a look at this patch and merge it in. And it was painful to create the patch file, it was painful to merge that in and to vet the changes. The other alternative was to become one of the committers yourself, which normally you could only do by submitting some patches. With a pull request model, what you did is you take a branch of the code, so you've got a fully built environment that works, a fully built source code branch that works. You can make those changes locally, and then if another person wants to take a look at your pull request, they can quickly look at your whole the whole piece of software that you've got, much more easy to see the change that needs to be made, and click a button and merge that back in. It gives you a lot of nice traceability aspects. It makes the whole process much easier. And many organizations found that this shift towards a pull request model for open source development was hugely empowering. So there's a lot of really interesting models out there for visualizations out there that people have done around source code and how source code changes over time. This is actually a visualization of the Ruby on Rails code base. And this is the period when it moved from being on Google Code or SourceForge over to GitHub. And what you see is a small number of committers initially. And when it hits a GitHub, about now, you have a huge explosion in the number of people that are contributing code. It's not just the number of people involved, it's also the sheer volume of changes coming in. This is amazingly empowering if you're working on an open source project. And it's no surprise that many projects move from SourceForge and Google Code and the like into GitHub because of this, making it much, much easier for people outside of the core team to contribute changes to your project. It didn't take GitHub very long to become the dominant player in the open source hosting market. It took about 3 years. 2011, they were handling more commits than both SourceForge and Google Code combined. Google Code, I think, has now been shuttered. And really, the only people we really talk about now are GitHub. Some things maybe are using Bitbucket, but that's mostly for corporate use. And other tools, of course, to the private space. But publicly, are you really going to create your open source project on anything other than GitHub nowadays? So, clearly I'm a fan. I like the idea and the empowerment of PRs in the concept of handling code. But of course, PRs are a form of branching. So don't I have all the same reservations regarding PRs that I do about feature branches? That's what they are, ultimately. The key thing to understand is where people mostly use PRs. PRs are used a lot in open source development. In open source development, if you're making a change, most people who are working on open source code are not working full-time on open source code. They're working in their bedrooms, in their studies. When they get home from work, they've got a couple of hours here, a couple of hours there. I might do an hour or two at the weekend. Any change is going to take a bit more time because you're not working on it full-time. And so just naturally, it's going to take you a while to check that change in anyway. It's also you're operating in an environment, traditionally, where you're talking about untrusted committers. This is a phrase used in the continuous delivery book. I don't necessarily like the term, but what it means is for an open source project, you have a core set of committers who sort of have certain levels of responsibility and accountability around that core project, and they have the rights to commit into mainline. And this is a way for people that aren't in that core team to contribute changes. Those changes will take longer because they're not working full time, and you do need to maybe vet those changes more because they're not part of the core committer team. Equally, I like using PRs inside organizations where you want to accept changes from outside of your team on your own code bases. But again, here's me working on my code base and my services. I own this, I'm accountable for this. Some other team wants to make a change in my code base. That's fine, but I'm kind of in charge. There's almost a review cycle that has to be gone through. And a PR in that model, I think, works well. And then, of course, there was Git Flow. So Git Flow is interesting. I tried to find a nice picture of Git Flow. This is the cleanest, most understandable picture I could find of how Git Flow works. Git Flow, because when something's worth doing complicated, it's worth doing complicated. This is a process, a sort of formal process of how you use branches inside Git. And there's actually command line tools of how you work with these branches. And so, you've got your master branch, your hotfix branch, your release branch, your developer branch. Then you have your feature branches all the way over there. And it's a sort of formal workflow for feature branch management. And it's a really interesting thing. It's quite, actually, when you get down to a very, very heavyweight process that just happens to have some tools that allow you to use this heavyweight process. And after speaking to a lot of people who use Git Flow and things, it seems actually to really be optimized for a model where people are working by themselves on a feature for a long period of time before then merging it in. And so there's a whole load of stuff to help you manage that process. But I don't know about you, but I don't like that way of working in software. I don't like the idea that someone's going to sit by themselves in general for weeks on end, working on a feature by themselves, and then merge that change in. We want these fast, frequent integrations, these fast, frequent releases. I've had other people come to me and say, but I use Git Flow, and we actually integrate every 2 or 3 days. To which I say, well, if you're merging really, really frequently, why do you need Git Flow? Just use as normal PR process or something. So I'm still really, really confused about what Git Flow exists for or why people want to use it outside of an open source project. So, of course, there's a lot of dogma around this stuff. I certainly have my views, as you clearly articulate, as you clearly have heard. But there are other views out there, many of which agree with me. In fact, how many people here have read the DevOps Handbook? There's a few people out there. So this is written by Gene Kim, John Willis, Patrick Dubois, and Jez Humble. And there aren't many books written by sort of more known people in a space in this DevOps book. And they cover a whole lot of different ways of how DevOps is used to help deliver software. And they make this observation in the book. Trunk-based development is likely the most controversial practice described in this book. So given all this time, these people still think, in 2017, when the book was published, that trunk-based development is still the most effective and efficient way to develop software. And it's kind of, well, what's driving that decision? And it seems to be based on not just the anecdotal experience of the authors, but also this. The data from Puppet Labs' 2015 State of DevOps report is clear. Trunk-based development predicts higher throughput and better stability, and either higher job satisfaction and lower rates of burnout. The State of DevOps report is a really interesting thing. It's been around for a number of years now. It's an academically rigorous study of development practices and team and organizational structures and practices, and how those things map to high-performing IT teams. So a high-performing IT team here is one with good throughput and low failure rate, and there's also some job satisfaction stuff in there as well. It's been going on for a number of years. Each year they try and expand the scope of this report. This is really, really well-researched stuff. The 2016 State of DevOps report corroborates what we found in 2015, saying, we found that having branches or forks with short lifetimes of less than a day before being merged into trunk and less than 3 active branches in total are important aspects of continuous delivery and all contribute to higher performance. Again, high performance meaning high throughput, low failure rate, job satisfaction. So does merging code into trunk or master on a daily basis. The key thing to understand about this report, and by the way, the 2017 report, which came out, I think, 2 weeks ago, concurs with this. The key thing to understand about this report is it's not saying that if you don't do this, that you're a bad person, or that your project doesn't work. It's just saying that statistically, looking across a large part of our industry, teams that do use these practices tend to be much more higher performing teams. You may well be the exception to the rule, but if you're looking at the performance of your organization, looking at the performance of your team, you're thinking, how can we get better? This is the kind of stuff you might want to look at, and there's loads more great gems in this report. It's a very short read, so I'd urge you to take a look at the latest version, the 2017 version. So am I saying that all branches are evil? Well, no, not necessarily. There are some kind of branches which I think are perfectly acceptable. Experimental branches, where you don't ever plan to merge it back. I think some kind of release branching is fine, where you're sort of just doing hot fixes out in a release branch, and those branches are never going to get merged back into master. Those are okay, I think, within limits. I also think that PRs, in an environment where you have untrusted committers and a core committer base, work really well. But remember that the work you do from 9 in the morning till 6 in the evening at your place of work is not like an open source project. It's a different thing. It's a collection of colleagues and peers working together on a problem. Together. You're not untrusted in that environment. I always keep coming back to this idea. If you're going to use branches, that's great. But keep those batch sizes small. If you're going to keep, that means if you're keeping your branch, if you're going to use branches, keep them very, very short-lived. Integrate as often as you can, ideally daily. That's what I like doing. And ship your software often. Whatever you do, if you're going to use branches or not use branches, you're using Git, or you're using any, Arch, or is Arch doesn't, maybe Arch does exist, or whatever else, or PVCS, or MKS source integrity, or Visual Source Safe. I've used them all. Whatever you're doing, just these mantras apply. Keep your batch size small, integrate often, ship often, and I think not only will you be happier, your customers will be happier too. Thank you very much for your time. I think I've got time for a couple of questions. I can't see anything, but I will do my best to see arms waving at me. Is there an arm over there? I can't see. There's a question in the middle there. Can you shout your question out for me? Oh, how about code reviews? So actually, I think code reviews are good. I like code reviews. I think the State of DevOps report actually has shown that that actually some form of internal code review is sort of highly correlated with high-performing IT teams. What they mean by that is a code review process done within the team process itself, rather than sending it outside of the team for someone else to look at. Code reviews can take multiple different forms. You can do a code review as part of a PR. And for untrusted committers, that's a big part of the process. You can get some of those same characteristics, benefits from pair programming. It's a different type of review, but it's still very beneficial. And you can also do what I like doing is like mob reviews. Like I've checked in this refactoring, or I found a new way of working, and actually getting like the whole team together as lunch and saying, should we work? This is great. The question for you is, how much of that review process do you want to be a blocking thing? With pair programming, it's in the natural flow. With a PR, that review process becomes a block to integration. And so you really do need to have some good guidelines about making sure you do your reviews frequently. Now, of course, if the things you're reviewing are small, the reviews themselves will be smaller, and it's less likely to be a blocking process. I find those mob sort of architecture reviews or mob code reviews that I do with a team around lunch or something are often something I'm more likely to do either on an experimental branch of code to try a new idea out, or after I've made the commit, just getting some ideas and feedback. So, any other questions? There's a question over there right at the front. Go ahead. Shout it out. Okay, yeah. So the question was, you got two modules, and I want to make some refactoring in one of those. Do I do a lot of changes and then sort of integrate and release that module, or do I do lots of small changes? I still like doing lots of small changes, but when you've got decoupled software, decoupled into components like modules or services, you do actually have the option of simplifying things a bit, because you could just decide not to release that module. So if you're putting together a piece of software that, say, consists of, say, 2 modules, and they're known versions of a module, then if you're doing a whole lot of change in that module, you don't have to branch it necessarily. You could just say, well, my software that I'm shipping, I'm using version 1.1. I'm actually working on the change in version 1.2, which is on head, but I'm getting an earlier version. So you don't necessarily even have to branch when you've got decoupled components. You could just not integrate with them. Yeah. Yes. There's a book you can read called Building Microservices where I talk about how you do it in an incremental fashion. There's patterns like branch by abstraction help. There's also a great pattern called the strangler pattern. I absolutely believe if you're decoupling code from microservice architectures or from modular architectures, you should do it incrementally, and there are techniques of how you can do that. I talk about it in more detail in this splitting services chapter. I think it's chapter 5. You can read the chapter for free at the Safari bookshelf. You go sign up 30-day free trial, and you can read that chapter by itself, and there's lots more stuff there. So hopefully that will help. We're out of time. Thank you so much, everybody, and I hope you enjoy the rest of the conference.